So thank you everyone so much for joining today. We're super excited to be here to be talking about how to build agentic AI with Temporal. And all right, we're gonna hop into some quick housekeeping before we start the content. So this webinar is going to run for 30 minutes. And if you have questions that come up throughout, please try to submit them down at the bottom of the screen in the Q&A panel. We actually have someone on the session today, Josh, who's going to be answering questions that come up as the webinar goes on. And then I have already seen a few questions coming up about whether there's going to be a recording sent out. So we will be sending a recording out to all people who have registered for the webinar after the fact, along with some helpful other links to learn some more. So we can start out with some quick introductions before we go ahead and get started. So my name is Megan. I'm on the product marketing team here at Temporal, and I'm going to be your host today. And I'm joined by the wonderful Alex Garnett, and I'm going to let him say a few words of introduction.
Thank you, Megan. I am Alex. I work on Temporal's documentation. I sometimes teach our courses, and today I am delivering this webinar about agentic AI. So I will just get right into it. Thanks everyone for being here. Uh, as many of us know, agentic AI is a complex distributed system. You are building a system that has to have a modular architecture that can interface both with external LLMs and third-party APIs that may receive responses that are probabilistic in nature, and it has to be able to handle them in different ways. You need to be able to scale to add volume depending on how many interactions you are receiving and how many LLMs and third-party APIs you are querying. You have to provide repeatability, so that way we have the same interaction if it happens multiple times. You have to be able to handle that in a graceful way, and to have durability. If you're thinking about the average chatbot or AI agent interaction, sometimes people walk away from their computers, they lose their network connections, and so on, and we have to be able to preserve state over the course of that interaction. So when you think about agentic AI, you should be thinking about an orchestration problem and a durability problem. Um, we have to orchestrate interactions across distributed data stores and tools. The agent has to track state in between queries and in between interactions with a human, as well as with other different data sources. We have to orchestrate multi-level processes. We have to keep retention for a long period of time, but then efficiently garbage collect afterwards so that we're not just constantly overloading a system with all the different conversations that could be spawned. We have to support human intervention over the course of that AI agent walkthrough. If you get a prompt to say, go ahead and book a hotel or book a train, we need to be able to do that gracefully as part of the AI agent workflow. We need to support parallel processing for efficient data retrieval and tool use. We're going to be making lots and lots and lots of queries in the background to all different kinds of data sources. And again, we have to be able to handle network flakiness or anything that might require automatic graceful retries or any edge cases that might arise just in the network infrastructure level itself. We need massive scalability to do this. This is an inherently unreliable use case, right? A lot of these third-party services can themselves be failure prone, and requests to them may time out. Requests to the LLM itself, for that matter, may time out because LLMs are often busy, and if you're building a layer on top of a big commercial LLM, you have to scaffold your connection to that LLM in a graceful way. Your agentic AI system has to be able to self-heal, and it has to be able to retry if it receives an error until the LLM returns valid data. And again, it's probabilistic. It's going to react differently to different inputs. We also have to be able to handle rate limiting from LLMs. Sometimes the LLM gets busy, and we don't want to show that to our users. There has to be some kind of orchestration layer to be able to handle all this. You know, we like to think of it as if you're doing AI work and if you're not doing like massive at scale linear algebra GPU AI training, what you have is probably an orchestration issue and actually just building an interface for people to actually use that AI. Agentic applications can also be difficult to debug and test. You need to have insight into an agent's performance. You need to know of all the different third-party services it has to interact with, which of those could be bottlenecking or causing your overall workflow problems, so that way you can cut over and potentially query a different booking API in the event that one goes down or is less reliable. But you don't get that visibility for free out of the box. You need to be able to add observability hooks to whatever workflow you have. You've got to troubleshoot across many different services, and all of this can be difficult to test pre-production. You wind up spending a lot of time on the orchestration problem and on the observability problem when you're just trying to build an end-to-end workflow for users. So, Temporal is a great solution for reliable and scalable AI orchestration. Temporal is a great solution for orchestration in general. And as we at Temporal were reading more and more and exploring more and more AI use cases, we were really chuffed to find that a lot of what we do well in orchestration in the first place is directly applicable to a lot of AI use cases. And we get you to production really, really quickly. With Temporal, you can code all of your business logic as workflows with a flexible, intuitive programming model. So there's no pseudocode here. You're actually writing code. You're just architecting your code on the Temporal platform. We have SDKs in Python, Go, Java, TypeScript, PHP, .NET, and Ruby, and that's just for now. There are more under development. And we support polyglot workflows. So you can have one AI agent that has to use some .NET code and some TypeScript code totally gracefully. We are a commercial open source platform, so we are really embedded in these developer communities, and we support creating more SDK languages as they suit your purposes. We handle that plumbing code for you. So ensuring every process executes reliably and provides guardrails for these LLMs. We can catch and intercept any bad responses coming from either side of the interaction, essentially. And then you have that scaffold for working directly with the LLM, and the user never sees that. Durable execution, provided by Temporal, makes those failures invisible and persist session data. So there's never a risk of losing anything if one of these many interactions being made in the background goes wrong for some reason. You can scale with a battle-tested product in Temporal. It's the exact same tech that powers critical apps at many leading companies, and it's a great application to building an AI agent. So here is what an AI agent architecture might look like without Temporal. And as you can see, there's all this stuff in here that just has to do with queuing and orchestration, because that's the problems you'll wind up solving a lot of the time. Like you'll have to have cron jobs that kick off all of these different chats and try to do garbage collection, so that way you're not storing all these inactive chat sessions indefinitely. The whole thing has to somehow be handled by some main message bus. That message bus may have to push some messages to a dead letter queue if they're undeliverable or a task fails. You have to be able to design that message bus in a scalable way, so that way you can keep adding more users and more agents on the back end. And somehow this all has to get persisted to a database so that you have that durability in the event that you have some downtime. Database scaling is hard in general, and trying to apply a session by session model to it doesn't make it any easier. With Temporal, we simplify that core component of your architecture to a significant degree. Because all of a sudden, you're not having to spend all your time thinking about queues and edge cases and message handling and persistence. That is all persisted by a temporal workflow and saved as needed in the database that backs temporal. So you're not actually thinking about database storage when you're working with a temporal workflow. The workflow is what persists all of your variables and delivers all your messages and handles them across your architecture. So by standardizing on a core temporal workflow, you can get automatic retries for any calls to third-party tools, and from the LLM API itself. Everything is handled in this one unit contained right here, and you can interact with it as an end user by adding hooks. So what's the impact of Temporal here? We can accelerate development by letting you focus just on your own logic and not on edge case handling. You can reach greater scale to achieve production more quickly and handle more customers without having to re-architect at different stages in your growth. You can sleep better at night knowing that you have some means of automatic recovery. If some of your workflows get stuck, it's very easy to scaffold in ways for them to work around that. You can build in different retry rules for different third-party APIs contained in different temporal activities. And you make your customers happier this way. That way you'll have more trust, more reliability. We're going to look at an example of a ticket booking agent application before I get into a fun live demo. So here is what the ticket booking agent that we wrote to demonstrate Temporal as an AI agent orchestrator looks like. It's going to book me a trip on American Airlines. And before I show that demo, I'm going to show you some of the architecture. Here is the basic interaction model. And if we take it at this level, we'll start really straightforward. We have a user interacting with a system back and forth. The user wants to take some action to achieve some goal, perform some booking with some third-party API. And the way this works is the user will back and forth interact with a system in plain language, provided some arguments. The LLM is able to parse out those arguments from plain language and turn them into actual booking criteria. And then at the end of the interaction, it will actually complete whatever your primary goal was. And then you're able to mark the workflow as complete. So as you're giving it more criteria, as it's trying to narrow and focus your request down, you just go back and forth. It might make some API calls in the meantime, and we get to the end, and voila, we have accomplished our task. Great. Here is a more complex model of the same thing. So we can see here the different interactions scaffolded by the temporal workflow as we're talking to an LLM, and then as that LLM is invoking tools to perform some kind of booking. We start with the human reading a prompt, sending some input. That will go directly to the chatbot UI, just the browser window we have. That browser window, the front end, passes it off to the temporal workflow, which is our main persistence backend here. The temporal workflow will then handle setting that input to the LLM. If it comes back as valid, the workflow can make sure that's good what we want to see. That workflow may then call an activity to some third-party tool. If we have to check, flight prices, it goes back to the chatbot UI, and then back and forth all the way until we're done. In case it has to get any corrections or clarify the input, we can just have a back and forth input model, which LLMs are designed to do. We just need to have this orchestrator in front of them to make this all work as a nice flow that is reliable and makes sense to users. If you're not familiar with temporal primitives, here's a brief overview. So like I mentioned, the temporal workflow is the main part of the application that defines the overall flow, and that's just written in whatever programming language that you're using. In this case, we used Python. So the workflow orchestrates the main event loop that your chatbot is going to work with you through. It's going to prompt the LLM and prompt the users. It's going to both receive some input through those hooks we build into the web UI and then send back some output. In Temporal, we call these signals and queries respectively. That's basically how you define input and output to a running workflow whenever you want to build in those interaction hooks. We keep a record of all those interactions because they are persisted in the workflow itself, and the storage is handled transparently by Temporal. And it executes all of the component parts durably and gracefully and handles any failure cases on the way to doing so. Whenever we call a third-party tool, that's a temporal activity, which is another temporal primitive. This is how you define functions or methods that might be prone to failure and might have to be called atomically and might have to be retried. And so if we don't get a response that we want back from, say, a booking or a lookup service, then we can call a different activity and we can handle that error or that edge case gracefully just by returning it back to the workflow and then telling it, okay, do I want to automatically retry this or do I want to try something else? The LLM itself can be any of several LLMs. Most LLM APIs are, at this point, relatively straightforward to code around. And this is a point I like to emphasize because the LLM ecosystem is fairly well developed, and there are a number of tools that are specifically designed for building with LLMs. Temporal is not specifically designed for building with LLMs. It's an orchestrator, but because LLM APIs are relatively straightforward and standard at this point, This is not the hard part in our eyes, right? Orchestration is the difficult problem. LLM interactions are just, you're sending some input and you're getting some output back. And so you can work with Anthropic, you can work with ChatGPT, you can work with any of several LLMs. We have in our demo code I'm showing you 5 different options, including an Olama API for self-hosted. So this part is pretty standard and it's pretty hot swappable if you want. We can even set it up so that if one of them is busy, you can just query a different one because the state is retained on the workflow side. This will drive towards a goal chosen by a user. It'll decide when to execute your tools. It'll parse those plain language queries for you. And this is also called by a temporal activity. Uh, as I mentioned, interactions are signals and queries, and you'll see how that works with our front end. And we get back to this architecture looking at the overall user and the system. So this is just a slightly more complex version of what we saw earlier. We're picking an agent goal. The system will prompt us. We respond just like a regular conversation. And we go back and forth, gathering arguments, narrowing down our goal until eventually we are able to complete it. And you'll see a demo of that in just a second. Temporal Cloud is our commercial offering. It is a very good way to host a temporal instance, and that gives you a nice, scalable, persistent backend that takes away a lot of the less fun parts of figuring out how to scale a local temporal instance. Temporal Cloud has support for security and encryption. It has very low latency, and it offers a UI for observability and management. So it's a great way to run temporal. Temporal workers are what actually perform the tasks that you define in your workflows. So the reason we draw a distinction here is your code doesn't run on Temporal Cloud. Temporal Cloud just hosts the orchestrator and the persistence layer. The temporal workers are what actually perform the steps that you define. And so you can scale those, you can host those on your own infrastructure. That way, if you have particular security requirements or you really want fine-grained scaling, temporal workers are what actually do the tasks that you define. They are the bones and the brain. They're durable and stateless. They persist state back up to cloud, which makes them very failure proof. And temporal workers are what run all those different runtimes for all the different languages we support. Here is what the main loop of our Python agentic AI example looks like. And it's slightly abstracted out for the sake of this presentation, but you can see here, we're just in a while loop. We have some wait condition. We're waiting to receive some additional input from a user. We're deciding if the chat should end and then return the entire conversation history for persistence. And then if we're ready to call a tool because we got some input that makes us want to call either the LLM or a third-party service, we can go ahead and call that tool. And then we're just back to putting more messages on a queue. And that's all that looks like. It's really used to the way that you would code in any other context. The only difference with Temporal is we give you all like the edge case error handling stuff for free in the back end. Otherwise, you're just writing code exactly as you would normally. So all in all, here we have a architecture diagram of everything that's going on here. We've got a user interacting with the UI and a front end. That's all going back up to the temporal workflow and getting persisted. The workflow is run by the worker, and that goes ahead and calls activities, which query the LLM or query third-party tools, and we get all of that sent back to the user via that same web UI until we are happy and we have made a booking with our AI agent. Pretty good. Let me go ahead and do the fun part, the live demo. So, whoops, let me get this out of the way. Sorry about that. And I will get this off my screen for now. And here we are. We have a running agent workflow here in a local temporal web UI. Show you here, it's giving me a prompt, and you can see that prompt reflected right here in this live temporal AI agent chatbot window. We're starting out. Hi, I can help you plan a trip to an event in Australia or New Zealand, find flights to get there, and create an invoice for your travel. Let's start by finding an event. All right. I want to go to Sydney in November because I know it's Southern Hemisphere and it should be warmer there than it is here. All right. We can already see, after having interacted with our AI agent, that we're logging some signals on the temporal side. Ready to run the tool, find events, Sydney, November, go ahead. This is really nice. We've done this for our demo just to make it clearer what's actually happening behind the scenes. If you think about a chatbot that you might see otherwise, it wouldn't show you like, I'm making an API call now, but we think it's helpful for the demo just to be able to see what's actually going on back there. I found Sculpture by the Sea in Bondi happening from October 23rd and November 9th. Great. All right. Search for flights. Where am I flying from? Well, I am flying from Los Angeles. I don't think they have flights out of Burbank, sadly. It's a much nicer airport. Going from LAX to Sydney, departing October 23rd and returning November 9th. Pretty good. Already, we've got the agent leading me down a really straightforward path. Apparently, I'm going to a sculpture festival and I'm getting to Sydney in November, just like I wanted. Go ahead and confirm that. You can see on the temporal side, we're running multiple activities every time we get some input from that workflow. Okay, ready to run the tool, create invoice. They found a flight for me, American Airlines flight AA203 for $1,262.51. Hang on a second, that seems suspiciously affordable. Is this an economy flight? Just want to make sure because all of a sudden, this agent's making deals pretty quick. I might be committing to being in economy for a long time. Yeah, it's economy. Okay. Well, you know what? That's fine. Let's go ahead and book it. I'm sure I'll get to stretch my legs when I get there, get to walk around the Sea Sculpture Festival. That sounds good. Go ahead and create an invoice for my trip. Very cool. Okay. We've generated our invoice. That is a Stripe link that actually goes to a real Stripe invoice. Look at that. We've been able to use the Stripe API to generate an invoice. I have the option to pay it with a credit card. And this way, I will be going to the Sculpture by the Sea event that the agent booked for me. Pretty good. So right here, we saw interaction with a few different third-party APIs. We had find events, search flights, and create invoice. Those were three different third-party services. We logged a number of activities and signals on the workflow side. Up above, we've got the entire chat history persisted in case we ever want to do any metrics on that. And down here, you can see a log of all the different activities that were created on the temporal side for each of those atomic events. And so invoice status, this was the actual amount it returned when it was booking the flight. So lots of nice fine-grained pieces here. All right. That was one demo, and I'm going to show one more really quickly that I also like. Just give me 1 second. I'm doing some stuff on my other monitor to prep that one. And here it comes. All right. One more fun use case. Let me just restart this. Et voila. And we're going to start a new chat. Whoops, I don't think that had come back up yet. Let me restart the other part of it too. Match train invoice. Let's see if I can. No, I think it's stuck in flight mode this time. It just loves booking flights to Australia. Hang on a second. Let me just see if I can give it a brand new session. No, it looks like we're just going to do the one demo for today. Unless I can restart the web UI. Give me one more second. I love doing live demos. You'll be unsurprised to hear it worked fine in, in testing. But if we just see one, that's okay. We'll have more time for questions. Yeah, it's not bootstrapping the other one, but that is okay. So I think we can cut the demo right there. The other one was going to be a cool part that showed both Python and .NET working together, but instead, let's go right over to the Q&A. So thanks everyone so much for this. I want to credit my colleague Steve Androulakis for putting together about 95% of that demo. And I'd love to hear about any other AI use cases that you have in mind that you'd like to see this adapted to. I can take a look at the chat because I know we've had some questions coming throughout, and my colleague Josh has been answering them. Some fun ones here. Okay, I'm just going to get into it. When do we get an Elixir SDK for Temporal? That, my friend, is up to you. Our gRPC APIs are open. We've had a community contributed Haskell SDK already. So if you want Elixir, I would say contact the Haskell guy and see how much fun you're having with that. Let's see, some good stuff here. Um, I saw a Temporal blog post that mentioned the TypeScript SDK uses isolated VM when executing workflows to enable determinism. Yes, that is a great question. So basically, the way Temporal works, and I'll explain this very quickly, is that workflows need to be deterministic to provide a guarantee of replay. And so if you have any non-deterministic code, that belongs in your activities. We provide some determinism safe functions to override typical low-level calls. Like if you're doing like time.now, we override that for you. So if you want user-generated code, that generally would belong in your activities to make some kinds of different calls, and you can parameterize that accordingly.
Right, and
From your perspective,
Alex, we probably have time for just one more question before we have to wrap up.
just one more question. Yeah. Okay. The last one I want to take here, because I spoke to this a little bit earlier, is from your perspective, does this replace the use of tools like LangGraph, or do you use this in tandem? That is a really good question. And I mentioned earlier that from my point of view, Temporal does solve a harder problem for orchestration than a lot of these other tools do, which is to say we handle all of that durability and persistence and storage and the retry aspect. Those are really challenging orchestration problems. LangGraph does a lot of other good things well, and it makes it easier to get up and running as a framework for just talking to an LLM. But in my opinion, scalability and persistence and durability are harder problems to solve, and that's why we like Temporal for this solution. And Megan, I'll give it back to you just for a second to wrap up.
All right. Thank you so much, Alex. Thank you everyone for the awesome engagement in the chat. So there was a ton of questions that came up, and I know we were all doing our best to answer them all. But if you have questions that have not been answered that you would like to get answered, we have an awesome Slack community where we have a ton of people who are always available and getting involved in answering questions. So you can find that on the link on the slide, t.mp/Slack, and we would love to hear from you there. There is a poll that we have just popped up into the Zoom, and we are actively planning additional webinars. So if you have requests of anything on that poll, please let us know what you would like to see the most. And I also dropped the link to the GitHub repo of everything that Alex has talked through into the chat, so you can find that all online, as well as our new Temporal Code Exchange, where there's a ton of different sample applications related to AI. So again, thank you everyone so much for joining. We really enjoyed the great engagement and hope to see you again soon.